This is lesson 25, covalent bonding. And covalent bonding is a bit more complicated than ionic. So covalent bonding is when molecules are formed by sharing electrons between atoms. And the reason why it's more complicated is because its Lewis dot structures are more complicated. So remember that covalent bonds occur between nonmetals. And in order for you to fully understand covalent bonding, you have to be able to draw Lewis dot diagrams, which show shared pairs of electrons as lines and unshared electrons as dots. So you can see down here that the lines are bonded pairs of electrons and the dots are non-bonding or unshared pairs. And in covalent bonding, you can also share more than one pair of electrons to form double bonds, or if you share 3 pairs of electrons, you can form a single bond. And as you go from a triple bond, and as you go from single to double to triple bond, your bonds get shorter and stronger. Bond polarity tells you how equally or unequally the electrons in a covalent bond are shared. Remember, if one atom has a very high electronegativity, it's going to pull harder on the electrons than the other. So if you subtract electronegativities and you get between 0 and 0.4, you have a nonpolar covalent bond. If you get between 0.4 and 1, you have a moderately polar covalent bond, for example, HCl. If you get between 1 and 2, you have a very polar covalent bond, for example, HF. And if you get above 2, you have an ionic compound because one atom will completely strip the other of electrons. So remember, nonpolar covalent bonds are when the electrons are shared equally. Polar covalent is when one atom has a greater electronegativity than the other, and this is also called a dipole, meaning that one end is negative and the other is positive, or slightly negative and slightly positive. And remember, ionic bonds are when the electrons are completely ripped away and transferred to form ions. In metallic bonding, remember, electrons are free to move between the metal atoms, and so you have what we call a sea of electrons. They don't really belong to any one nuclei, they're shared between them all. So, to draw a Lewis dot structure, the first step is to add up the total number of valence electrons. If you have a negative charge, you need to add electrons. If you have positive charges, you need to subtract electrons from the total. Put the atom that wants the most bonds in the middle, and then place the other atoms around the central atom. Then you'll place the remaining electrons into the diagram to satisfy the octet rule, meaning that all atoms have 8 electrons surrounding them. If you don't have enough electrons, you know you need to use multiple bonds, so you have to go back and use multiple bonds to adjust your Lewis dot diagram. Now, what about if you come up with more than one Lewis dot diagram for your molecule? Well, a way to check your Lewis dot diagram is by using formal charge. The formal charge is the charge an atom would have if all of the atoms in the molecule had the same electronegativity. So to find the formal charge on an atom, you'll take the number of valence electrons for that atom minus the number of bonding electrons in your Lewis dot structure minus the number of unshared pairs in your structure. The sum of the formal charges should equal the overall charge on the molecule or ion. Then you pick the Lewis structure where the atoms have the formal charges closest to 0 and the negative charges are on the more electronegative atoms. And we'll do numerous examples of these in class as well. Okay, so here's an example. Assign the formal charges in the cyanide ion. So we have cyanide Cn-, and cyanide has a triple bond, and you know that there is 10 electrons because 4 from carbon, 5 from nitrogen, and 1 for the negative. So the formal charge of carbon is 4 valence electrons minus 3 in the bond minus 2 unpaired for a total formal charge of -1. And nitrogen is 5 valence minus 3 in the bond minus 2 unpaired for 0. So the formal charge adds up to -1. Now, if you had drawn your Lewis structure differently, incorrectly, for example, 2, 4, 6, 8, 10 electrons without a triple bond, your formal charge would have been 4 valence minus 2 in the bond minus 4 non-bonding is -2, and the formal charge of nitrogen is 5 valence minus 2 in the bond minus 2 unpaired is +1. you can see that even though they both add up to a -1 total formal charge, they are not the lowest possible numbers. Or let's say you had drawn a double bond, but this time you put 2 lone pair on nitrogen. And so your formal charge of carbon would have been 4 minus 2 in the bond minus 2 unpaired is 0, and nitrogen would have been 5 minus 2 in the bond minus 4 is -1. So here I would say you have an argument for formal charge. However, remember that Lewis dot structures like to be as symmetrical as possible. Okay, here's another example. Draw the possible Lewis dot diagrams for SO3 and determine the formal charge on each atom for each Lewis dot diagram. So sulfur likes to go in the middle. It has 6 valence electrons plus 3 times 6 for O, so that's total 24. And we know sulfur likes to go in the middle because it's bigger. So we put the 3 O's around it, and then we fill in 24 electrons. So we start giving each 8 oxygen 8, and we realize sulfur must have a double bond in order to get 8 around it. So we have our 24 total electrons. But let's say you also drew your Lewis dot diagram with all single bonds around oxygen. Sulfur would not have its octet, so we know this one's probably wrong. So let's find the formal charge. So sulfur has 6 valence electrons, minus 4 involved in bonds, minus no lone pairs is positive 2. This oxygen has 6 valence electrons, minus 1 in a bond, minus 6 unbonded for -1. This oxygen is the same. And this oxygen is 6 valence electrons, minus 2 in the bond, minus 4 for 0. So -1, -1, 2. This sulfur is 6 valence electrons, minus 3 in bonds, minus 0 non-bonded for plus 3. And each oxygen is 6 minus 1 in bonds, minus 6 is -1. So -1, -1, -1, and positive 3. We can see that the first Lewis dot diagram is the correct one because it has lower formal charges. They still all add up to 0. Resonance structures are Lewis dot structures in which the atoms are in the same place, but the placement of electrons is different. So here's a question: draw the Lewis dot diagram for ozone. So ozone So here's another example for resonance. Draw all 3 resonance structures nitrogen. So here's an exception. Draw the Lewis dot diagram for Fe.